are all the topics you need to know, plus a few example problems. These example problems are very similar to what you'll see on the test, so use them as a gauge of kind of what maybe you're okay at, and then what maybe areas you need to focus your study on. So as we go through this video, what's going to happen is the sub is going to pause it because I want you to try the problem on your own first. Okay, the way I want you to do it is first, before you talk to your neighbors or look at your notes, read the question and see if you can do anything. Okay? If, after reading the question, you have no idea where to go, then the next place I want you to do is to open up your notebook, go back to that section of your notes, and review it and see if that kind of sparks some ideas of where to go. And then finally, you can talk to a friend about it, and then when you are done with it, or you're to the point where you don't really know where else to go, put your pencil down on your paper, and when the majority are done, the sub will play the video, and then you can check it and make sure you're doing it right. But do help each other out. If even after this video you still have questions, ask those around you, and hopefully somebody can clarify it. Okay? All right, here we go. Okay, so the first topic that you need to know for the test is percent composition. So percent composition, as a reminder, is where we're finding the, also known as the mass percent of the elements in a compound. Okay, so for example, if I wanted to find the mass percent or the percent composition of sodium carbonate, Na2CO3, what we have to do is we first have to find, I'm getting ahead of myself. Pause the video, try it on your own, and then press play, and we'll answer it. Now that you've tried it on your own, let's go through it. So, first thing that we need is we need the total mass of the compound. So I see that there is sodium in this compound. So when you look at the periodic table, underneath sodium, you see that it has a mass of 23.98. Because there are 2 sodiums in the formula, we need to times this number by 2. Okay. Carbon has a mass of 12.01, right? And these are coming from the periodic table. In the formula, there's just one of them, so that's good. Oxygen has a mass of 16.00, and there's 3 of those in the formula, so times it by 3, we end up with 48. Okay, now we take all those numbers and add them together, and you should have hopefully got a total of 107.97 grams. Okay, so then the next thing you're going to do is once you have the total, is we need to find the percent of each of these individual elements. So to find the percent of sodium, if you look back in your notes, the equation is you take the amount of sodium, so the total amount, so that 47.96 over the total, and then times by 100. And I got 44.42%. Okay, let's do for carbon. The percent of carbon is 12.01 on top over the total times by 100, which I got to be 11.12%. Okay, and then finally the percent of oxygen, 38 over 17.97 times by 100, and in the end we get 4.57%. Okay, and these are the percent compositions of sodium carbonate. Okay, if you need to, feel free, if you need to have the sub pause the video so you can talk about it more, feel free to. If not, let's move on to the next question. Okay, so go ahead and pause the video here. Try the problem on your own, and then start the video up and check to see how you did. Okay, so this question is that given a percent composition, we want to find the grams. So it's kind of doing the reverse of what we just did. So this one tells us that in what is sulfuric acid, 32.7% of it is sulfur. If I have a 150 gram sample of the acid, what is 32.7%? So to find the percent from a total, we're going to take the total total mass. Take the total mass of 150 grams, and we're going to times that by the percent, but we have to change the percent back to a decimal. So you're going to times it by 0.327, and in the end you should have got 49.05 grams of, and that is your answer. Okay, so percent composition was the first part of this unit. The second part of this unit was when we did empirical formulas. So let's review really quick. So an empirical formula in general is the simplest whole number ratio of a molecule. It simply tells us the ratio of the things in there. Okay? So you need to be able to know how to calculate what an empirical formula is. Okay? So for example, stop. Pause the video, and then we'll come back. Okay, so we're trying to find the empirical formula of a compound that has that percent of nitrogen and 74.1% oxygen. So the process of finding an empirical formula is step 1, you have to be in grams. So since we're in percent, remember we just do the simple little trick of saying, well, let's say I have 100 grams of the sample. Because if I have 100 grams, then that really means that I have 25.9 grams of nitrogen and 74.1 grams of oxygen. Okay? So we just assume we have 100, change the percents directly to grams. Step 1. Step 2 is you have to convert to moles, because moles is what compares the ratio. So, grams to moles, we're going to use that little road map. So since grams is here, grams goes on the bottom, mole goes on top. This just comes from the periodic table. You divide it through, and we find that we get 1.848 moles of nitrogen. Okay? Same thing, we gotta do it for oxygen now. So we'll set up our fraction. Oxygen has a mass of 16 grams in every 1 mole of it. When I divide that through, I get 4.631 moles of O. Okay, so an empirical formula has to be a whole number, and these are definitely not whole numbers. So what we have to do is we take the smallest of them and divide it through the rest to get them to be a whole number ratio. So since 1.84 is the smallest, we're going to divide that one. Okay, so this ends up being 1 mole of nitrogen, and this ends up being 2.5 moles of O. So we're better off than we were before, because now nitrogen is a whole number, but this is still a fraction. And it's not close enough to round, so this is a situation where then we times them both by 2 to get 2.5 to be a whole number. So our final answer for the formula is 2N05. That is the empirical formula based off the information given. And that's a process you'll follow every single time you're trying to find an empirical formula. Alright, the next topic that you need to understand is how to calculate a molecular formula. Okay, so remember the molecular formula is the true formula of what something is. Okay? So try out this problem where if they give us the empirical and the molar mass of it, see if you can find me the molecular. So pause the video again, try it on your own, and then check it here in a second. Okay, so our process here of finding a molecular formula is the first thing we have to find is you have to find the empirical formula's mass. carbon has a mass of 12.01. That comes from the periodic table. Then we have 8 hydrogens. Each of those has a mass of 1.01. Times it by 8. So total is 44.11 grams. Okay? Find the mass of the empirical. Next step is you're going to take the mass of the molecular formula, and that should be given to you in the problem, and divide it by the mass of the empirical formula. So our molecular formula mass, it tells us, is 88. What we calculated was 44.11. Calculate that out, we get 1.995, which is really close to 2. Okay? Remember that this number should always be a whole number or extremely close to it. You never should be multiplying this by a factor. That's only in the empirical formula process. So now what we do is we're going to take that 2 and times it through the formula. So we end up with a molecular formula of C6H16. And that is the molecular formula, the true formula of that compound. Okay, so first thing you need to know, percent composition. Second thing is empirical. And finally, the third thing, what we've been working on most recently, is nomenclature. Okay, so you need to be able to name covalent, ionic, and acids. So, pause the video, name these 3 things for me, and then check and see how you did. So the first thing, remember, with naming and formulas that you always have to do is you have to identify what type of bond it is, because that's going to tell you which rules to follow. So I look at this compound, N2O6. Nitrogen is to the right of my diagonal, which tells me that it is covalent, which tells me next I'm going to use prefixes. So you should have dinitrogen, hex, ox, and it always ends in I. Dinitrogen, hexoxide. Okay? Come to this one. 2 things here. Magnesium is left to the diagonal, so that tells me it's ionic. Or there's a polyatomic, and polyatomics are always ionic as well. So since it's ionic, it tells me that I don't use prefixes, I just name the 2 pieces. So magnesium, I then look to see, do I need a Roman numeral? In this case, I don't, because magnesium is in the first 2 columns. And then OH, that's a polyatomic, so you just look on your list. And you should have magnesium hydroxide as your answer. Okay? Finally, I come to this last one. I see my H. That tells me it's an acid. The next thing you look for is, since there's multiple elements attached to that H, it tells me it's a polyatomic. So you should look on the back of your sheet, find SO3. Since SO3 is sulfite, ite with acids turn to us, so your answer should be sulfurous acid. Okay, and then the next thing you need to be able to do is you need to be able to go in reverse. Given a name, you should be able to write the formula for me. So go ahead and pause the video, try these on your own, and then, you know the drill, start it back up and see how you did. Alright, so just like before, you need to know what type of bond it is so you follow the right rules. First one here, I see a prefix. That tells me it's covalent. Covalent means we just change the prefixes to numbers. So phosphorus doesn't have anything, so I just do a P. Pentachloride, that means Cl5. And there's your answer. Okay, next one here, I see no prefixes, I see no acid, so I know that it's ionic. And when you hear ionic, the next thing you think is charges. You have to do the charges. So sodium, bring that down, Na, has a +1 charge. Carbonate's one of your polyatomics, -2 charge. Switch them away. We should have Na2CO3 as your final answer. Alright, then finally I see the word acid, which tells you it's an acid. I look at this name, hydrophosphoric acid, must mean that there's a phosphorus squished in the middle there. Phosphorus on the periodic table has a -3 charge, which means I'm going to need 3 hydrogens to balance it out. And that should be your answer. And then finally, the last part of the test is where we're translating words into an equation. What we did kind of last time and what you'll practice of more today. So read this equation, write out a formula for me or an equation, and then check it and see how we did. Alright, so first thing I would do once again is figure out where your arrows and your plus signs are. So this says that lead-2 nitrate decomposes when heated to yield. To yield means it's changing, so that's our arrow. Excuse me. And it's yielding lead-2 oxide, comma, that means a plus sign. Nitrogen dioxide, plus sign. Nitrogen dioxide, there's your next plus sign. And oxygen gas. Okay? So we have lead-2 nitrate. Lead-2 is its charge. Nitrate is NO3 with a minus charge. We have to crisscross them, so you get Pb and O3, and the 2 goes outside. So we have lead-2 nitrate decomposing to form lead-2 oxide. So lead-2 oxide is just oxygen. Periodic table tells me oxygen is 2 minus. They are the same, so they cancel, so it's just PbO. Then we have plus nitrogen dioxide. That's covalent. Don't have to do charges because there's a prefix. And then finally oxygen gas, which should be O2 because it's diatomic when it's alone. Okay? So that's it. That's an overview of everything you need to know for the test. Maybe make a mental note of the ones you couldn't do on your own and make reference to go back and review them. Remember, you have an online review assignment that is a great practice for the test to see how you're doing. I'm going to have 2 review assignments posted, so you can do it once and then you can do it again rather than doing the reset thing this time. Or if you like your first score, you don't have to do it again. You'll also be able to find an extra credit online naming and formula practice for those that feel like they want more practice before the test. That's available to you as well. Okay? Help each other out as you continue to prepare the rest of the day for the test so you can be as ready as possible. I'll be here Monday morning for A-Day students. If you have some final questions to come see me, I should be here by 6:45 a.m. And then B-Day students, you're also welcome to